Okay, so good afternoon. I'll be talking about the platform service we have here in Rakuten. We based our platform as a service using Cloudfoundry. But first, of myself, my name is Valdemar Quevedo. You can call me Wally. My Twitter is WallyQS. I have a GitHub account also, WallyQS. I'm originally from Mexico. I joined Rakuten as a new graduate in 2010, originally as an application developer, and then moved on to the RPaaS project when it was during the foundations of the team, and I mostly helped with the logging and Ruby runtime support in the platform as a service. Previously, I have talked about the logging infrastructure that we developed for Cloudfoundry installation. It's in SlideShare already, just so you can access later if you're interested on how we solved the problem of logging. We used Cloudfoundry, and because it makes sense to us because Cloudfoundry is Ruby itself. Anyway, this is if you want to get more into the details about what we did about logging. So first of all, what is RPaaS? As the president previously mentioned, it's a platform as service that we can use in Rakuten. It's sort of like a fork of Cloudfoundry, and we started providing production level support since mid-2012. That's when we launched. So we have been using it in production for a bit more than a year now. So this talk is going to be a bit about the lessons and the insights that we have gained from having taken the leap of the classical DevOps to a much more automation-oriented DevOps. And also, just one fact is that Derek Collison, which is the guy who used to be in VMware and now he has his own company and a very smart guy, he wrote the original source code from the Cloudfoundry, and we made him like a technical fellow of our team for giving us advice about the future of the platform as a service, and very smart guy. So one example of a site that's running in the platform as a service is actually this. The tech.rakuten.co.jp site is itself running on RPaaS. In case you notice that we do have like the cute logo at the bottom of the site. Yeah. So this is one example of production application that where it's in production, we could call it. Okay, so I'll be talking about why is it worth to have a platform as a service internally. I think that platform as a service itself is something that you will eventually have to do in order to improve the life of your developers. If you want to make the application teams more agile, you will run into the problems of guaranteeing having high availability, having to scale on demand as fast as possible according to the business, the needs from the business. You will need to either scale horizontally by increasing the application, or you will need to scale it vertically to a much higher performance machines. And you will need all of this. I mean, the topic is we're engineers, so we can automate all of this, right? So the original problem, one use case, for example, when you scale, how do you go from this, for example, this is sort of like in the DNS kind of like configuration setting. How do you go from having like one IP mapped to one domain to like suddenly like having all of these different IPs, and how do you, instead of mapping just one IP to one domain, map several IPs with a port to a same domain to increase the to scale up the application just in a matter of seconds. If you're familiar with Heroku and this all of platform as a service, you are familiar with this flow already. I mean, of being able to use like increased instances +5. So we have the same thing. For example, here you want to increase the number of instances from the tech Rakuten.co.jp site. You can just say +3 instances, and you would have now 4 instances running of this site, and it would make the provisioning, everything behind the scenes, and as an application developer, it's very streamlined for you in your operations. So this is one of the benefits, is that it makes you more agile as a developer, because I mean the key factor is that you can focus on the application itself, writing the application itself, and not on maintaining the servers. Yeah, you can delegate maintaining the servers to the people that are running the platform as a service. And since it's just like these command line based operations, they're more simplified. You don't have to write these huge release operation manuals and be like step by step, like yeah, I confirm this, then I confirm this other thing. All of this is automated, so the release task becomes much more faster. So how does a release is actually done with a platform as a service app? Sorry, well, I hope you can see it, but so first you push the application. For example, you push a new version of the application, and when you push it, you map it to the currently mapped domain. So I have some comments here, but they're difficult to see. Sorry. And so after you push the application and you map it to the domain, there's going to be a window of time where the application is going to be balanced between the old version and the new version until you unregister the previous application from the other domain, from this domain. So this is your whole release, like no downtime release, and it's very fast. I mean, as fast as you can like type these commands. Yeah. So, as I said before, the benefit is that you empower the application team to have these better practices instead of being like manual operation and doing, if they're not skilled enough to do automating everything, you empower the team to having these more streamlined releases, because it's just like RPaaS push and mapping domains. And since it's like an internally available platform as a service, you are within the network of the company, so you can connect to all of the available internal APIs and services. Yeah. So there are many more like merits of why is it worth it to have one. But today I will be mainly talking about taking the leap of having adopting an application platform as a service internally. Yeah. So the thing is about delegating, having to care about the servers, and then you have this like we call ourselves the RPaaS team. So instead you can rely on us to making the developers' lives easier. So I mean the usual metaphor with DevOps is vampires and werewolves. How many people are familiar with this metaphor of vampires? Very few people. Yeah. Okay, so the metaphor is the application developer. They provide value for the business. They provide value for the business, and they need resources. They need to deploy their application as fast as possible. And in this metaphor, they're sort of like vampires, sucking the resources and sucking the money, right? And then we have the werewolves as the system administrators. And the system administrator, on the other hand, they want to protect the value. They want to keep the current value. They want to at least guarantee that we have this value, and instead of like having this risk from these guys, right? And decreasing the risk from these guys. So it is a battle in sort of sense, because you have the application developers wanting to release their bugs into production, and then you have the application, the sysadmin saying that we can't release this. I mean, it's unacceptable for us. So just have these guys like pushing backwards the application developers, and you have this, you cut the innovation a little bit. Yeah, so it happens like this, right? I want to deploy my code, and then the sysadmin is, I need to know more about your code. Is it this Java, is it Node.js application? What do you expect me to do to deploy this stuff for you? I need more info, right? So when you start using a platform as a service, the interactions, they change a lot. There's a, instead of, there's this change into delivering faster, right? Because instead of like protecting just the value, you focus on making the application team developer be able to innovate faster. So the keyword is to make the user deliver more things faster, more value. Yeah. So I want to try using a different metaphor in this case. Instead of vampires against werewolves, is I would call it like villagers and samurais. Yeah. So are you familiar with the Seven Samurai movie here? So you have the villagers, right? And the villagers have tons of issues they're being like robbed, and people taking away the resources, and they cannot solve the problems on their own, and they're currently like helpless to do anything else, right? So these guys, the samurai team come, and they help the villagers to be able to they help them with their issues, right? So I see the interaction changing from being like providing value and protecting value to one where the platform as a service administrators, they have the application team solve all of their issues as in a very automated way, in a very flexible way, so that they can deliver more. Yeah. So I want to try using this metaphor from being like application developers against the system administrators to more like a cooperative flow, and so it's like a villagers and samurai. Yeah. So in this case, the interaction would be the application developer says, I need to deploy my code, and the past members would be, it's totally possible. We enable support for this Ruby or this web server that you want, and you just have to use RPaaS push, and that's it for your operations. So, since you have to be, as one of the members of the platform application team, platform service application team, you need to externalize all of this that the application team developer is not caring anymore, right? So we use this phrase a lot in our team, is you should know everything. Yeah. So in this case, I would like to summarize it into you should know about your whole stack. This means that knowing about Cloudfoundry, the Nginx, the services that you're providing, the NoSQL databases, and all of that stuff. You need to know about the environment itself. You need to get very, very familiar, deeply familiar with the infrastructure. How is the network behaving? Yeah, you need to know about your users, know the demand from the users, and I also call it knowing the capacity. What can you actually deliver? Yeah. So I want to talk a little bit more about these four points. So first one is know your stack. Just as a question, how many people are familiar with Cloudfoundry here? Cloudfoundry, okay. So it is, the architecture is actually very simple. You have these components named the Cloud Controller, PA, and well, the architecture is sort of like this. So you have a router, a component named the router that it's actually an Nginx doing the reverse proxy to the applications, right? And we call them the DEAs, the Droplet Execution Environment, which if you're looking at a dictionary, it's actually a terrible name. Yeah. And you have the health manager, like monitoring that that all of these applications are being have not crashed and are receiving requests and everything. And then you have an API that is basically that controls interaction with the user. Like when you RPaaS push, you are talking actually to this cloud controller, which is a Rails application. And of course you have database, and it is you have some connections here, and this is actually provided by the message bus. So all of these components are connected by a message bus named NATS, also written by Derek. Yeah. So when we're talking about knowing your stack, you really need to get familiar with all of the failure scenarios from this distributed system, right? For example, what happens if the head manager suddenly dies, right? I mean, that is like one of the pieces with the less impact, but for example, what happens when one application crashes? In this case, what would happen is the head manager is going to notice that there are no heartbeats anymore, and is going to spawn another instance to recover as soon as possible. So it's self-healing. But overall, you need to worry about for example, when one of the physical hosts go down, right, and there is no unregistration message or anything. So if you do this, the router will eventually stop sending requests to this application. It is not displayed here, but actually the worst thing that could happen is when the message bus goes actually down. That's like the catastrophic scenario, and you need to like research, like unplug things and do this, prepare yourself with partitioning the network so that you have this majority minority stuff. And so the next thing I want to talk about is you really need to know your environment. Yeah, you're doing all of this for the users again, right? So are you guys familiar with the fallacies of distributed computing? No? Okay, I'm going to click the link. It's, well, that's it. I just messed this up. Yeah. So what are the fallacies of distributed systems? Basically, when especially for me, since I'm from an application developer background, I used to be writing Ruby on Rails applications on my spare time. I was not from a system administration background, but I wanted to really improve the lives of developers here at Rakuten, which made me motivated to start working in this platform as a service team, because it's a huge pain to not have these systems that make everything easier for you. It's a bit frustrating sometimes, but so the fallacy is the network is reliable. There is no latency. The bandwidth is infinite. The network is secure. The topology doesn't change. And these were also added. The transport cost is 0, and the network is... so it's all of these fallacies that, as an application developer, you take for granted. Like TCP IP will just work. It will never fail. There's never going to be nothing wrong on that level. And I always have enough bandwidth for my application. Yeah, but if you can remember one, it's just the network is not reliable. Yeah, that's the biggest point from this. You don't just trust that the network will work. Yeah, everything will fail at some point. Yeah. So to get back here. Yeah, so you're doing all of this for the users, right? So do not be afraid of bringing up this TCP dump and start checking the packages among different nodes, because we run into this. We had to do this especially when deploying a new data center, right? Because you expect the next data center is going to have similar behavior from the previous one, right? It's no. Every data center has its own issues. It has its own workarounds that you will need to do all of this tuning on your configuration management. Yeah, so you need to specialize that your whole platform as a service deployment can work on different data centers, and this is getting familiar with the environment each time. So, so that's one thing to be aware of, the environment, right? And also the trouble scenarios. I mean, everything can fail. We actually have run into all of this. I mean, the storage will fail. Your disk will become read-only, and the physical hosts, we use virtualization from this, and the physical host can go down at any time. So that's why you need to really focus on having all of this being highly available. And that I said this here, but this is the name of the message bus from Cloudfoundry. And actually, if this one goes down, it's the catastrophic scenario that I previously mentioned, and it will go down. We have run into this. It has gone down, and we need to do these post-mortems and recover as fast as possible. The next thing that I want to talk about is getting in touch with your users, right? So since you are providing a platform as a service, especially during the adoption that we're doing, because it is the first year that we have been running platform as a service, you need to do an extra effort for the users. Yeah, so there's this essay from Paul Graham. I don't know if you about doing things that don't scale. And so basically, there's this common saying about it is ironic that you're helping the user so much, because eventually it will not scale. And as a platform as a service, you are supposed to be scalable, right? But especially during the adoption phase, you will really need to get with the users and give them one-on-one support, and really do things that do not scale. Yeah, especially to increase your user base and make your platform as a service successful. Yeah, so we really care about the users in this time and in our team, and especially when Cloudfoundry was released a year and a half ago. There is a roadmap mismatch from the guys from VMware that they really want a public public platform as a service, but we want a private platform as a service. It seems like the VMware guys, by default, they don't care much about the downtime for an application. For example, you push an application to this public platform as a service, no one is going to notify you that your application has gone down, or no one is going to be accountable of your downtime that you have. I mean, so in our case, we need to really be accountable of anything that goes down, right? So we need to have all of these, the private platform service, it has to be very, very auditable. You need to have logging, you need to monitor all the things, you need to keep on billing, keep on track of how many CPU resources have been used by all of the users, and be able to develop as a team. And Cloudfoundry by default didn't have all of these features that were blockers for us. So we had to develop the logging infrastructure for the Cloudfoundry project. It's a house-based solution. We had to extend it with monitoring, building capacities, also make it able to push applications as a team with organizations. And I think latest versions of Cloudfoundry already have this, but it was very, very only a long time to the roadmap. So doing this also for the users, because otherwise we cannot comply with the regulations, internal regulations from the company. At least for the logging, we need to have all of the application need a certain amount of. You need to have all of the logs from the application for a certain amount of time. Yeah, otherwise the application cannot go to production. Yeah. So this is in respect of knowing the users. The next one I want to talk about is knowing your capacity. So many times, because the misconception from the cloud, but we often get asked, like, what about autoscaling? Why are you guys like don't provide autoscaling? I want, like, if I have this certain amount of pattern traffic and you identify this pattern, I want to be able to autoscale, increase the number of instances. From our experience, that is not usually what you want to do. I mean, autoscaling is sort of a myth. I mean, as a PaaS team member, you do need to make everything to be provisional as fast as possible. And we do this with Chef. I mean, we have a lot of Chef repositories to provision new components on demand. But autoscaling for users is something that we really don't consider. Yeah, I mean, the user knows about the traffic he's getting, and eventually he will notice that maybe the performance from the application is decreasing, and I will just spawn another instance. So we don't do this autoscaling at least in our installation of platform as a service. And instead we monitor all the things, check the trends, and when there is we see where the trend goes and increase the resources for the application. So increase the disks and increase more provisionable and NoSQL cache services. Or in the case we're getting more popular, we're getting more requests per second, we increase the Nginx. Yeah, Nginx solves many things, right? The more Nginx for everything. So going back to the users, you really need to manage the user expectations. So there's this saying about under-promise and over-deliver. You really need to make it clear for the users what you can actually deliver, and not default on the usual concepts that people have from the cloud, right? So many people think that as a cloud, you should be elastic. It should auto-scale. You should self-heal. You should have all of these features that I am expecting. Like, you will solve all of these problems. If you can solve these problems, you really need to document a bit about the capabilities of what you can deliver. Otherwise, we have run into problems, for example, like, I mean, in the platform as a service, it's possible to scale vertically. You have your current instance, and you suddenly need a bigger, with a higher spec machine, and there were people that were thinking that you guys should do this automatically. Yeah, I don't have to like do any action. It should be elastic, right? But there's still this threshold where the actual business needs to be solved by them. So you need to increase the awareness of what is your concept, what is possible for your platform as a service installation. And the next things in this regard is, I previously said that we're like samurai for the villagers, but many times there's this saying about the RPaaS team will fix it first. Yeah, and many times you have this issue with for example, a connection pool this connection pool issue with the client library from very famous, I don't know, Redis library from Java, and people start complaining about it's a problem with RPaaS, and they will investigate what's going on with our application, right? Yeah, so it really helps to getting familiar with all of the, as I said previously, you should know everything. So you need to get familiar with the most popular libraries and get awareness of the usage from what your users are doing on production. But you really need to put like a line where you can say, no, I mean, you guys have this like architectural issue that you guys need to solve on your own. And what I see from this is that you make the platform service users like sort of like collaborators. I mean, giving feedback to each other so that your application improves and the platform service becomes more flexible. And I'm not ready for, I'm almost to wrap up. So just for okay. Okay. There are some times for questions. So just to wrap up, we're very proud of what we have accomplished in this almost 1.5 year now. But we recognize that the platform as a service install that we have is still very premature technology. We call it first, second generation technology. And we already see that the industry is, where is it sort of heading for the next generation. For example, when we started, Ruby was the thing, right? Ruby was the language of the cloud in soft sense. I mean, everyone was saying that Chef will solve everything. I mean, all the provisioning, you should do it with Chef, or you should do it, other people use Puppet, and this was the way to go, right? And there was this very famous tweet. This is DevOps, the practice of letting developers run Ruby as root, right? And if you see nowadays, you see that Go is being much more attractive. And actually, Derek himself said, Derek who wrote Cloudfoundry in Ruby originally, now tells us that, guys, Go is going to be the thing that will you guys will be using instead of Ruby now. He said this within 2 years, Go is going to dominate the whole cloud industry. Yeah, and also you see, mainly because it has very high performance, and also because of Docker, that it has been gaining popularity recently. Yeah. So I think that's it for the contents of my presentation. I would like to do a quick demo of of our tool, if it's okay, and then start for like Q&A. If you guys have any questions, maybe.
Yes, we have about 15 minutes to have for the Q&A session.
Yeah.
So just a quick break. Yeah.
Okay.
Yeah.
Yeah. So I will do a quick demonstration of how RPaaS works. Yeah. So hopefully the network. I'm still connected to the Wi-Fi. Yeah. I will be using the account from the guys from deploy the Rakuten site. So this is actually the VM, the application, and it is possible to take a look at the logs that these guys have. And you can check the stats from the latest deploy. Yeah. So in this case, I will increase the number of instances just for today because we have more users, we have attendees and everything. So this is how you scale up in RPaaS. Plus one. Scaling instances to 2, and that's it. That's everything you have to do. There is no workflow to apply, there is no permission to ask to anyone, no teams involved, it just happened. Yeah. You have this application on production, you need more resources, we have more attendees today, let's increase the instances to 2 now. It was only 1 instance so far. So. Anyway. Yeah. And you see that you have a new instance with like less than 1 minute of uptime now. Yeah. It's possible. We also have a tailing support for the logs. This because of the network, but it works. And also, 1 second. Any questions so far? Yeah.
Yeah, I have a question.
Yeah.
So how do you version the environment? Like if you see some security update or important update to be applied to the environment, so how do you apply the update?
Environment in which context? The application context or the actual platform as a service?
I mean like middleware layer, like or we have to apply agent 1.4 something in production like that.
Yeah.
So how do you
So that would be, since you want to upgrade, so we have this, okay, I can show you the runtimes that we have. Yeah, so the past members like make available these runtimes for you. So if you want to increase like one piece of the technology from this, it would be like modifying one of the runtimes. So you are demanding a new runtime. So it would be like a support ticket for us like to investigate this new runtime and then just like make the fix to the upgrade. And so there is still this collaboration that needs to be done. Yeah, I mean we don't do things that users do not need, basically. Yeah.
Each application can use different. Yeah, I would do what you say, but
yeah.
Yeah, I mean, so the path is kind of shared environment, and
Yeah.
It's like a new technology of web hosting.
Yeah.
And this kind of technology, all application or all users sometimes has to use same version or same.
Yes. Yes.
I believe you can divide that. So you have to.
Yeah. So as I said, that this is like first, second generation technology for us. So right now we're like very runtime oriented. You have this predefined runtime that predict that has deterministic behavior for us. We know how it works, and we make this available for you. But we see that in the future it would be sort of like that, because I think we'll be moving to containers eventually. So you have these pre-built containers, and then you add some packages that you want, and like sort of customize it for your own use. Yeah. So, but right now it's like all or nothing approach. Yeah. Am I answering your question?
I guess so.
Okay.
And also I have another question. So how your path is handling database or backend? So
Backend.
like a database or like a backend process.
Yeah. Yeah. So we have so in the context of the past, we call this services. We have services, and basically you bind. You bind.
Should increase that size of
Okay.
font.
Sorry guys. This okay?
I guess so.
Oh, this is better. In the context of platform as a service, you have services, and it's sort of hard to see here, but you can create a service, bind it to your application, and bind it to your application, and this would restart your application and inject one environment variable to your application so that you can connect transparently to the your service. Yeah, so you only care about connecting to this environment variable from your applications and never change any IPs or anything. So it's very transparent in that sense. Yeah. So it's binding and unbinding services. Yeah. Basically. Yeah. Is it okay?
Yeah.
Okay. Any more questions? Yeah.
Could you share about your lesson learned about using Cloudfoundry? For example, things that Cloudfoundry sometimes is updated and version 1 and version 2 are very different.
Yes.
And how
So
can we solve the difference of the base and the middleware?
yeah, basically we sort of gave up on the next version of Cloudfoundry. And well, not yet maybe, but we still use B1, the version number 1 of Cloudfoundry, because by the time Cloudfoundry 2 came, we had already solved all of the problems from Cloudfoundry 2, so there was no gainings for us, and so we are not considering right now moving to the next version of Cloudfoundry. It's okay.
Okay. Okay. My question is, you consult in your talk Docker.
Yeah.
Yeah. My question is, which is your recommendation to to invest to Cloudfoundry or Docker with other general distributed resource managers such as Yaron and Mesos? Do you catch? I mean.
Yeah.
Such frameworks doesn't support operational issues such as web services specific, such as routers and health managing and application deployment. But these frameworks produce not only for web services,
Yes.
but also produce a platform for big data analysis. Do you think about it?
I'm not very familiar with Mesos. I do think that Docker is the future. I mean, containers, and maybe like Cloudfoundry is a bit limited because it only considers web processes.
Yeah.
But you need to automate much more, right? You need to have batches.
Yeah.
You need to have big data services that, as mentioned. Yeah. Regarding the big data stuff, if you use our platform as a service, it transparently sends stuff to the big data. Yeah, but I think, yeah, I think if Cloudfoundry were to be built today, I think we'd be using something like Docker instead. Yeah, for containers. Yeah, so we can discuss later in a talk. Yeah.
Okay, yeah.
Yeah.
Thanks.
Yeah. Any more questions? I think it's 1 minute left.
I'm sorry the time is up, so if you like it, just stay here and talk to directly.
Okay.
And we're going to have a 15-minute short break, and the next session will start here and at 3 p.m. o'clock. And just enjoy yourself here. Thank you very much. Thank you, Wally.